So hello and welcome to the 5th video in my Moog Prodigy restoration series, and finally we're up to calibration, which is pretty exciting. So I've set up to do the first calibration already, which according to Moog is called alignment and adjustment, not calibration. So I'm doing the first one, which is the temperature adjustment. So firstly we start with the power off on the board and then put a short across R17 and R38. And then we measure either pin 5 of U2 or pin 5 of U4, depending on which oscillator we're doing. So here we go. I have set up a short across R17 and another short across R38, and the first one I'm going to measure is oscillator 1, so the probe is on pin 5 of U2, pin 5 of U2, and we're getting 0.689 volts. Now what we're supposed to do is remove the short from R17 and watch the voltage drop, but it's not dropping. It should drop 60 millivolts, but it doesn't, so something's wrong. Hopefully it's just not adjusted. So we're going to adjust R14, which is the trimmer for the temperature adjustment on oscillator 1. If I turn it all the way one way, well, we're not dropping 60 millivolts. All the way the other way. In fact, we're not dropping anything now. 0.687, it hasn't moved. So that's all the way one way, and then all the way the other way, and it hasn't changed. Okay, so it's fixed. I'll explain how I fixed it by looking at a schematic, because it'll be a lot easier to understand. But we'll do the calibration for now. So I've shorted out R17 again, and the voltmeter is reading 0.687 or 88. So when I remove that short, I need a 60 millivolt drop for 22 degrees ambient temperature. Now I'm slightly cooler than that. I'm at about 20 degrees. So I need a slightly greater drop than 60 millivolts, but we'll do it and we'll do the adjustment. So the short's off and we're dropping from 0.688. Need to drop below 0.628. So there's our 60 millivolts. That would be right if the room was at 22 degrees, but I'm not, so I need a little bit more drop than that. So let's just adjust. Now I'll take a look at the circuit and explain how I fixed it. Okay, so here's the schematic for oscillator 1 of the Moog Prodigy, where I've highlighted in red that part of the circuit is the heater, which is what we're trying to calibrate, and the top part is the oscillator. So in the heater circuit, 2 of these transistors are in the transistor array with the 2 from the main oscillator. So anything in a box is in the same array, and when you find a transistor in it with a circle, that's just a standalone transistor by itself. So this one up here is the actual heater. This transistor is used as a heater. This standalone transistor is just used as an on-off switch to turn the heater off and on, and that one is controlled by an op-amp that's been configured as a comparator, as an analog comparator. So normal comparators would be, say, 0 volts and 5 volts output, whereas this one could swing between the supply rails. This transistor is used as the temperature sensor for the chip. Has a sensitivity of about -2 millivolts per degree, I think. And this is our trim pot, what we're adjusting. So what we're adjusting is one of the inputs on the comparator. So this comparator checks the voltage that's coming out of this transistor and comparing it to what we set it at. So if it's different, this guy will either turn this heater off or on to heat this guy up, or let the chip cool down, which the temperature will then be picked up by this transistor and cause the comparator to either turn off or on. So what we're doing in calibration is we short out this R17, which turns this off. So that stops the heater from working. So the heater isn't working and we're at room temperature. And then when we unshort this resistor, this transistor turns on, the heater turns on, we get a temperature change registered at this one, which is where our probe is. And then we adjust this guy according to how the service manual says to get the right temperature, which ends up to be about 55 degrees in the middle of the die on the chip. So when I was adjusting this, I couldn't get any difference in this voltage. I would move this all the way, one way or the other, and I wasn't seeing any change. So either this comparator is not turning on or not turning off or something like that. So the first thing you do when troubleshooting this circuit is just replace all the active components. So the first thing the service manual says is just replace this transistor array, which I did, and it didn't make any difference, so that was fine. So I put the old one back in now. Second thing I did was replace this op amp, so that's 1/2 of this op amp. Then I replaced this transistor, and it still wasn't working. So I replaced this guy, and this guy, and it still wasn't working. So I started actually looking how the circuit was functioning, and when I adjusted this, I got the comparator turning off and on just right, so the voltage was coming out here, which was good. I checked all the continuity to all these tracks and it was all fine. It's all connected properly. Eventually traced the fault to this transistor not turning the heater off and on, so this transistor wasn't working. So the one that I replaced probably had the same fault as the one that I took out. So then I tested a good transistor, make sure I had a good one, then put it in the circuit, and then it's fine. So our problem when I was adjusting initially was that we weren't turning the heater off and on because this switch wasn't working. So we were never going to register any temperature difference on the temperature transistor where we were measuring here with our probe, because there was no change in temperature. Okay, now for oscillator 2, so it's the same adjustment, we're just doing it in different places. So the short now occurs over R38 and the probe we're measuring pin 5 of U4. So the meter is 0.665, so I need a drop of just over 60 millivolts because my room temperature is lower than 22, so probably aim for about 0.602. So we undo the short, and you can see as the die heats up, we get the voltage dropping, and that's pretty much exactly where I want it to be. Okay, so next is the keyboard scale adjustment, so the CV from the keyboard. So the probe is just on pin 1 of U12, and the pot for adjusting is R92. So we start with just the low F key. Hit the low F key, should be 0 volts, ground, and then an octave higher. Should be 1 volt, and an octave higher than that. Should be 2 volts. So that's good. Next is the oscillator tuning. So we do each oscillator separately. But before we start, we need to zero the tuning pot. It should be, according to the manual, electrical 0. So it's not the pot necessarily all the way straight up, although I think that's not a bad idea. But the manual says make sure it's electrical 0. So you need a probe then on the middle pin of that pot, and you move that pot until you get as close as you can to 0. So the other end of the lead just goes to ground. Wherever you want to pick up ground is fine. There's also ground up here. So you're just measuring the voltage across this voltage divider. So one side will be plus 12, the other side will be minus 12, and somewhere in the middle you should get back to ground, which I've done. And then after that, we just turn one of the oscillators up. So I've turned up oscillator 1. I'm on the lowest range, so this is 32. I've turned the volume up. I've turned the filter wide open and the resonance down. So the filter is open, and I've just had the sustain on full and the release on full, so I get quite long notes. Just turn that up a bit. Okay, and then I'm using my trusty iPad as a tuner, which is much easier than using a frequency counter. And when we sound our notes, the adjustments that we do are made on these pots along the back, which can be accessed when the cover is on. I'm just doing it with the covers off. So the pots here, one is for the actual frequency trim and one is for the scale, so for the slope. The easiest way to remember which one to adjust is that when you hit the low key or the key on the left hand side, you adjust the trimmer that's on the left hand side. And when you hit the high key or the key on the right hand side, you adjust the trimmer that's on the right hand side. That's the easiest way to get it right. If you adjust the wrong trimmer, you actually put it out of tune and it gets worse and worse and worse until the trim pot goes all the way to one end and you can't adjust anymore. So if that's the case, you'd have to take the trim pots back to the center position and start again. Okay, so let's do the tune. We're going to start with the low F. It's a bit sharp. So just I've got to get the screwdriver in. There we go. High F, so 2 octaves up, and then adjust the frequency. I think I finished oscillator 1, F1, F3. That's pretty good. So next for oscillator 2, you just use a different set of trim pots. You use these two, and you need to make sure that you're listening to the right oscillator. So I'll turn oscillator 2 up, oscillator 1 down. I've still opened up the filter, and I've still got the sustain and release on high. So the other part though with oscillator 2 is that you need to not have them synchronized. So there's no sync, and the interval needs to be at 0, just the approximate 0 that you would leave it if the panel was on. And then it's just the same procedure as the first oscillator. So you just do the keys, and then you use the trim pots to tune it. So I'll do that now. I think I've done oscillator 2. So it's F2. And F4. So F2 and F4, because the range doesn't change as much on oscillator 2. Well, the range doesn't go as low. So on oscillator 1 it would be F1 and F3, oscillator 2, F2 and F4. And then you're also supposed to do it on the highest scale possible. So we're still on oscillator 2. So that could be adjusted a bit more. We'll do the same for oscillator 1. Yeah, and that could be adjusted a little bit more as well. So then after you've done that, you just do the trim pots again a little bit on the higher range, and then you change it back to the low range and do the same thing again and adjust the trim pots if you need to again. And you just keep going between high range and low range until you're kind of happy that it's all right and it's in tune. So it's not too difficult, but it is easier with the cover off. But definitely you could do it with the synth assembled, because you can get access through the back to these trim pots, and in that case you would just put this pot at where you thought 0 would be. So the tune, you just put an approximate 0, because it'd be hard to measure it electrical 0 with the covers on, but it should still work out the same. So that's it for the tuning. Okay, so we're up to the filter calibration. The first part, the manual's not very clear. It says to set the filter frequency to 0. That doesn't mean you turn the pot all the way to 0 like the scale is written on the front panel where you've got 0 and 10. It means electrical 0. So if you try and do it the other way with the pot all the way around, you won't be able to calibrate. So you put the probe on the center pin, because this again is just a voltage divider. It's -12 and +12 on the other one, and in the center you should be able to get ground. So you adjust that as good as you can to try and get 0 volts. So that's at electrical 0 now. Now what we want to do is turn the filter tracking off, and then we sound the low F key, and we're supposed to use where are we? R113, so this trim pot, to tune it, believe it or not to F but to E. We're not setting up any harmonics right now, we're just tuning the pot to the center of its range. So it doesn't really, because this key's F, it doesn't really mean anything. All we're doing is setting up 0 from the keyboard, and we're centering the pot. So what we want to do now, sound that, and we need to get to E5, which is 660 Hertz. So we move this pot It's very sensitive. It's pretty close. E5. So that's the first one done. That was R113. So now we've set up 0. So then next is the scale and the range of the keyboard tracking for the filter. So all of these adjustments, including the last one where we zeroed this, you need obviously to have it self-oscillating so the resonance is all the way around. So to do this one, we'll need to move this pot to something a bit lower. So I'm going to try and get it to F3. Okay. It's pretty close to F3. It's very hard to adjust because the pot's so big, you need a fine tuner really. Okay, so that's about F3. And then what we want to do is 2 octaves higher on the next F. We want that to change to F5. So we need to turn the keyboard tracking on. So this is actually a really hard adjustment. So for the lower key, you just use the filter frequency pot. And for the higher key, the high F, you're using R122. But what makes it really difficult is you need to adjust this pot in the exact opposite direction that you think. So if you're lower, you need to adjust it so it goes even lower. And then once you adjust the low key again, you'll find that the high key is closer to being in tune. If you adjust this pot on the higher key towards where you want to go to, it actually ends up further out, so it's quite difficult. So we need to adjust further away from F now. And then on the lower key, do our frequency pot. It's close enough. So our high F, it's pretty close now. It's almost identical. If I could tune the low key properly, it would be in tune. So difficult. Smallest movement of that pot and it sends it completely out. Here we go, F3. F5. It's already drifted. But they're nearly identical. So that's adjusted now. So it's exactly 2 octaves between our first F and our second F. So that's it for the filter. Okay, next is the VCF balance adjustment, and I can't remember all the settings off the top of my head, so I'm just going to read them off the screen. So the mod rate is fully clockwise, the mod shape is the square wave, the modulation wheel's full, the cutoff frequency is fully clockwise, the emphasis is 0, and the filter mod is on. All the oscillators and the mixers are down to 0, and the contour amount is 0. And we put our probe on pin 7 of U17B. So, I've done all the settings, square wave, mod wheel full, the rates full, all the oscillators 0. The filter is open and the resonance is 0 and the modulation is on. I think that's it. So many settings. What we're doing is we're adjusting R143 to make pin 7 of U17 equals 0 volts. It's pretty close anyway. I can't attach my lead because I'll short 2 pins of the chip. So I can't really do this while holding the camera, but I'll just put my probe pin 7. You can see it's 0 volts. And I got to that point by adjusting R143 until that pin 7 read 0. So that's the VCF balance. Last calibration is the VCA balance adjustment. So it's not as easy as just attaching probes to the board and measuring stuff. We actually have to take a signal from the LFO. We take a 30 Hertz square wave from the onboard LFO and we inject it into the VCA, and we use that to do the balance adjustment. So the first part is to set up to extract the LFO. So I've attached the lead to R102. Can't really see, it's in the shade of the light. Hang on, move the light a bit. There you go, R102, the top of R102. That connects to pin 1 of U13. So in the service manual it says attach the lead to a probe to U13 pin 1, but it's a bit difficult to do that, so I've taken it from the resistor instead because it's the same connection. Then on the other end of that lead we attach a 20k resistor, and then we will eventually put that into the VCA, but first I've just attached it to my multimeter and make sure that I've got a 30 Hertz signal, which I do. So just to show you, to get our 30 Hertz signal, we adjust this, the LFO rate. So if I turn that now, you'll see I get a different amount. So we increase the frequency to 30 Hertz first. And then once we've got that, then we can attach the other end to the voltage control input of the VCA. Okay, so our lead goes on the emitter of Q28. Okay, there you go. So now we've put our signal into the VCA, and we measure from the output of U17, which is pin 1, but again there's a resistor next to it which is connected to pin 1, so I've used the resistor instead. So that's R127, the top of R127 connects to pin 1, U17, and then we adjust R129 to get the minimum AC voltage. So there's quite a big swing actually. So you watch, turn it one way, goes all the way to nearly 40 volts. And the other way there'll be a dip and then back up again, 38 volts. So I've got to find the minimum. So about 0.25 volts is the lowest I can get. So that adjustment's done. So that was the VCA balance. So that completes the calibration. So we're done.